Hi, hi everybody. Myself Mahesh Shirur. So today I am going to the model 4 of applied hydraulics, that is in model 4 part 2, that deals with the turbine. Okay, before going to explanation what is meant by turbine, these are the mechanical machines or the instruments which convert electrical energy, hydraulic energy into electrical energy. Okay, so this figure which you are seeing is the layout of the hydroelectric power plant. So this is the layout of the hydraulic power plant, okay, which consists of the dam. Okay, then this is the penstock of a large pipe which is made of a steel or the concrete, and here it is the nozzle for increasing the velocity of the pipe, and here it is a tail race in this box which receives the water from the penstock or the velocity which does not hit the veins or which is hitting the veins, and it will be collected in a tail race and it will be discharged out. Okay, so before going to explanation, then what is meant by hydraulic machines? Okay, they are the machines which convert either had hydroelectric energy into mechanical energy is called turbines. Okay, next we'll understand what is meant by pumps. The hydraulic machines which convert mechanical energy into hydroelectric energy are called as pump. Okay, the in the layout of hydroelectric power plant, which consists of the following. Okay, a dam constructed across a river to store water. The water in the reservoir is referred to as head race. So you are seeing this is the head race which stores the water at the upstream side of the dam. Okay, then secondly, it consists of a pipes of a larger diameter called as penstock. So these are the pipes. So this, suppose this is the dam. Okay, and this dam is connected with the pipe of a larger diameter which is called as penstocks, which carry water under pressure for storage of reservoir from the storage reservoir to the turbines. Okay, this is the turbine. They are made of a steel or reinforced concrete. So this penstock of a used pipe, they are made up of a steel or the reinforced concrete. Then third one, turbines vanes fitted with the runner. So this is the runner and this is the turbine vanes. Okay, which will, when we hit force of water will wetting, it will be rotating. Okay, then tail race. So this is the tail race. Okay, a channel that carries the water away from the turbine after the water has worked on the turbine. The surface of water in this channel is known as, so this tail race. Okay, so let us discuss the definitions of the what is meant by. So this is, so from this top level of the water to the bottom level of the dam, that is called as cross head, that is hg, and from head race at the top level of this, and when the water is flowing from the dam to the penstock, and there will be decrease in the water from the horizontal line to the inclined line, that is called as head loss due to friction. Hf is equal to 4 flb square upon 2z. Head loss due to friction means because when water will enter to the penstock, the friction will be created in this penstock of the pipe, so it is called hf. Okay, so from this hf to the penstock level, it is called as net head. Okay, then this is the tail disc. Okay, so let us discuss about the definitions. Okay, here you see, so gross head, what is meant by hg? The difference between the head race and the tail race when no water is flowing is known as gross head. So this is the gross head, so hg. So this is the head race and this is the tail race. So this portion is called as gross. That is defined as the difference between the head race and the tail race when no water is flowing is called as gross head. Next comes to the net head. So this from this portion to the top level of the penstock, it is called as a net head. That is, it is defined as the head. It is defined as the net head available in the inlet of the turbine. Okay, it is also called as effective head. This is also called as effective head. It is defined as the net head available in the inlet of the turbine. In the head raised to the turbine through a penstock. A head loss due to friction between the water and the penstock occur. So that is called as head loss due to friction. When water is flowing from head raised to the from head raised to the penstock to the turbines through a penstock, a head loss due to friction between the water and the penstock will occur. So this difference is called a head loss due to friction. Then that is given by HF is equal to 4FL square upon 2GD, where F is the friction resistance and L is the length of the penstock and V is the velocity of the flow in the penstock and D is the diameter of the penstock. Okay, therefore net head is equal to cross head minus head loss due to friction HF, that is H equal to Hg minus HL. Okay, so this is the definitions and explanation of this hydroelectric plant. Okay, next coming to the definitions of the efficiency of turbine. So after just finding the various components of the electrical layout and various parts, next we have to find the efficiency of that machine or that the turbines. Okay, that is given by first one hydraulic efficiency, that is neta H. So it is defined as the ratio of the power given by the water to the runner of the turbine to the power supplied by the water at the inlet of the turbine. So mathematically NH, okay, hydraulic efficiency NH is equal to power delivered to the runner divided by power supplied to the inlet. Therefore, NH is equal to runner power divided by water power. So, power divided by the runner means that is runner power. Then power supplied by the inlet means water power. So, NH is equal to RP divided by WP. Okay, hence runner power is equal to RP is equal to work done per second divided by unit weight into weight. That is equal to work done per second is equal to VW1 minus the velocity of work done by 1 plus or minus velocity work done by 2 divided by 1 by g, the acceleration due to gravity. This is initial velocity into weight W. Okay, therefore therefore water, water power is equal to net head into weight, that is equal to H into weight. Therefore NH is equal to, that is hydraulic efficiency, NH is equal to velocity of water plus minus velocity of water to W2 divided by G into H into U. Okay, so next one is mechanical efficiency, that is given by NM. What is meant by mechanical efficiency? Okay, the power delivered by the water to the runner, that is runner power, is transmitted to the shaft of the turbine. Due to mechanical losses, power available at the shaft of the turbine, that is shaft power, is less than the runner power. The ratio of shaft power shaft power to the runner power is called as mechanical efficiency. So mathematically that is mechanical efficiency En neta m is equal to shaft power divided by runner power. Okay, that is nothing but the ratio of shaft power to the runner power. SP means shaft power, RP means runner power, is called as mechanical efficiency. The value of NM varies from 97 to 99% depending upon the size and shape of the unit. Okay, next is volumetric efficiency. So what is meant by volumetric efficiency? Okay, the volume of a water striking the turbine is slightly less than the volume of water supplied to the turbine. Okay, when the water is flowing from the dam to the penstock and penstock to the turbines, all the water that will be supplied from the penstock to the nozzle, it will not hitting to the blade. Some of the blades of the vanes of the turbine, some water will be escaped, that is collected in the tail. Okay, so the volume of water striking the turbine is slightly less than the volume of water supplied to the turbine. This is because some water get discharged to the race without striking the runner. Okay, therefore the ratio of the volume of water actually striking the runner, the ratio of the volume of water actually striking the runner to the volume of water supplied to the turbine is known as volumetric efficiency. Therefore neta v is equal to 97 to 99%. So always efficiency will not be 100%, it will be 97 to 99%. Then next one is overall efficiency. Okay, it is defined as the ratio of the power available to the shaft of the turbine to the power supplied by the water to the inlet of turbine. Okay, therefore NO means overall efficiency is equal to shaft power divided by water power, that is equal to SP divided by water P WP, that is N naught equal to a short power divided by water power SP divided by WP, that is varies from 85% to 95%. Okay, so next one is the relationship between NH, NM and N naught. Okay, that is hydraulic efficiency NH, then mechanical efficiency NM, and overall efficiency NO. Okay, we know that overall efficiency NO is equal to shaft power by working power. Okay, water power, not working power. Therefore multiply and divide RHS right hand side by RP. So SP WP as it is given, we multiply and divide by RP. Therefore RP divided by RP, on rearranging we will be having N naught overall efficiency is equal to RP into WP into SP into RP. Therefore N naught overall efficiency is equal to NH into NM. So where is NM is equal to mechanical efficiency and NH is equal to hydraulic efficiency. Therefore N naught is equal to overall efficiency is equal to mechanical efficiency into hydraulic efficiency. Okay, thank you.